Hi everyone, this is teacher Justina and welcome back to my YouTube channel. For our video today, it will be all about solution of a system of nonlinear equation using elimination method. So let us explore. Okay, so when we say solution of a system, it is an ordered pair that makes all the equations in the system true. The solutions can be real or complex. However, we will only deal in this video all about real solution. So what do you mean by real numbers? So sometimes the solution will be a real number. So another is sometimes the solution of a system can be complex number. So when we say complex number, it is a number that has two parts, the real part and the imaginary part. So this example, 3 plus 2i is an example of an imaginary or a complex number. So 3 is the real part, then 2i is the imaginary part. In elimination method, we eliminate one of the variables in both equations. Then we will solve for the value of the remaining variable because we have eliminated already the other variable. So when is it easier to use the elimination method when solving systems of linear equations? So we are going to consider the different steps. Step 1, eliminate one variable by adding or subtracting the two equations. Second, solve for the other variable in the resulting equation. Then the third step, we are going to determine the value of the variable you eliminated by substituting the value of the other variable in one of the equations in the system. So let us have this example. Okay, so let us try this example. So find the solution of this system. So we are going to decide as to what variable is to be eliminated. So far we need to consider the following condition. Look for a variable with an opposite signs. That will be the first. The second is look for the variable with the numerical coefficient similar. And then at the same time, you look for the variable with similar degree. And so far, the conditions, the three conditions satisfy to eliminate y because it satisfies the 3. So therefore, we will be eliminating the variable y. So how to eliminate the variable y is to uh, add them vertically. So how to add them vertically? We are going to have this. So 3x squared plus x squared will answer 4x squared. While this one is already eliminated because it answers 0, and then 24 minus 8 will be 16. So since we will be getting the value of x, we need to divide first both by 4. So this time, x squared is equal to 4. So since we need to get the value of x, we need to extract the square root both sides. And remember, we are going to isolate the exponent of x because we are extracting its root. So therefore, x is already the square root of positive 4 is positive and negative 2. So therefore, our first value of x is 2. The second value of x is negative 2. So the next is we are going to look for the value of y. So in getting the value of y, we need to use any of the two equations. So we will be using the first equation, 3x squared plus 3y squared is equal to 24. So in getting the value of y, when x will be positive 2. So what will be the value of y if x is 2? So therefore 3, the value of our x is 2. And then plus 3y squared is equal to 24. And then you know that 2 squared is 4 times 3, we have 12. Plus 3y squared is equal to 24. So we have to get the value of y, then we have to have 24 minus 12. And then 3y squared is equal to 24 minus 12 is 12. And this is over 3 both. Therefore, y squared is equal to 4. So the values of y are positive and negative 2 because the square root of 4 is 2. So our first y is 2 positive and our second y is negative 2. So in this case, we are done finding the value of y if x is 2. Now we are going to solve for the value of y if x will be equal to -2. So we will still use the same equation. We have 3x squared plus 3y squared is equal to 24. Now we will be using -2, so 3, then the x is -2 plus 3y squared is equal to 24. Then you know that -2 squared will be 4 times 3 will be 12. And then 3y squared is equal to 24. Then 3y squared is equal to 24 minus 12. Thus, this is all over 3, all over 3. Then 3y squared is equal to, no, it's already uh, divided by 3. So therefore, it's already y squared. And then 24 minus 12 is 12 divided by 3 will be 4. And therefore, getting the value of y, we have already y is equal to positive and -2. So what are the solutions of the system? So the solutions of the systems are, if x will be 2, this one, we will pair it to, our y here is 2, and then at the same time, at 2 also will be paired by -2. But if our x is -2, we have also the two values of y in here. We have -2 paired to +2, and still a -2 will be paired to -2. So how do we know if these four solutions will satisfy to the system? So let us try check. Okay, so far the different solutions to the system, we have 2, 2, -2 and 2, 2, -2 and -2, -2. So how do we know, or how are we sure if they are really the solutions to the system? So we are able to check using its pair. No? So the first equation is 3x squared plus 3y squared is equal to 24. Then substituting the 2 for x and substituting 2 for the y. So for the first equation in the system, using 2 to satisfy, as well as the second equation, which is x squared minus 3y squared is equal to -8, also satisfies. So the -2 and +2, substituting them to the system, it also satisfies. Then the third solution is 2, -2 still satisfies, while the last solution to the system also satisfies. So far using the elimination method, we're able to get the different solutions to the system. We have 2, 2, -2, and +2, 2, -2, and -2, -2. So if we are going to try the graphical method, we're able to use the I am using the Desmos graph application, and so far, as you can see, that our system is made up of an ellipse and a hyperbola. So the four solutions to the system using elimination can be found as the point of intersections of the ellipse and hyperbola. So as you can see, we have all the four solutions to the system using elimination. At the same time, we have the 4 points of intersection of the two graphs. Okay, so let us try this example number 2. So far, the variable to be eliminated is, we are going to look first the signs that are different. So far the y has different signs. So we have a +3 and a -6. So if we will be eliminating the value of the variable y, we cannot eliminate them because they have different numerical coefficients. We have a 3 and a 6, although they have different signs already. So all we need to do is to look for a number which is a multiplier to our first equation in such a way that we will be obtaining a numerical coefficient same with as 6. So all we need to do is to look for that multiplier. So what will be a number multiplied to 3 that will give us a 6? So of course, we have a 2. So that 2 will be multiplied or distributed to the terms on the left and a term also on the right. So what will be our new equation? Our new equation A. So our new equation A is now, so 2 times x squared will be 2x squared, 2 times 3y squared will be 6y squared, while 2 times 52 will gives us 104. And our second equation will be remained as is, so we will be rewriting this. So we have rewritten that already because we are not making adjustments. So now, so since our variable y has opposite signs, at the same time they have similar numerical coefficient other than the positive and the negative, we are going to proceed now to addition. So we are going to add them vertically. So what is 2x squared plus 4x squared? So far this one, when will be added, the result will be 6x squared. And of course, this will be eliminated. And 104 plus 46 is equal to 150. So to get the value of x squared, we need to divide first by 6. Thus, x squared is equal to 150 divided by 6 is 25. So to get the value of x, okay, so therefore, we have the values of our x, which are positive 5 and negative 5. So our first root, or our first value of x is positive 5, while our second is negative 5. So how to get the value of y? So getting the value of y, okay, if x is equal to 5. So let us use original equation A. So we have x squared plus 3y squared is equal to 52. So what will be the value of y if x is 5? So we have this 5 squared plus 3y squared is equal to 52. And this is 3y squared is equal to 52. That's one. And that 5 squared will be 25. When transposed, that will become negative 25. And 3y squared is equal to, what is 52 minus 25? It will be 27. So therefore, we will be getting the value of y already. 27 divided by 3 is 9. And getting the value of y, we have positive and negative 3. If we will be substituting the value of x into negative 5, we will still come up with the same value of y. Let us try. X is equal to negative 5 because as we have seen, we have our first value of x, which is 5, and the negative 5. So are we coming up with the same value of y? So we still have to use the original equation A. Okay, so therefore our x is negative 5 plus 3 times y squared is equal to 52. Then that negative 5 squared will be positive 25 plus 3y squared is equal to 52. So we have 3y squared is equal to 52 transpose the 25. So therefore, we have all over 3, and in all over 3, y squared is equal to 27 over 3. Thus, the y squared will be the y values are the square root of 27 over 3 will be positive 9, and the square root of 9 are positive and negative 3. So therefore, for that, we will be having now the solutions to the system. If it is 5, if x will be positive 5, we have the two values, positive 3 and a negative 3. So again, 5, then we have also a negative 3. If we will be having a negative 5, the two values of y are positive and negative 3. So if x is negative 5, the two values are positive 3 and negative 3. So therefore, these are the four solutions to the system using elimination method. So okay, so we have the four solutions to the system, and we want to check if they really are the solutions to the system. So far, when checking the 5, 3, So far, the system satisfies as well as 5, negative 3. It also satisfies until negative 5, 3, then negative 5, negative 3. So therefore, the four set of ordered pairs are solution to the system. Okay, so let us proceed to another example. Let us have this number 3. Okay, so far we are going to uh, decide as to what variable is to be eliminated, and so far in this given example, the y minus 2 squared has opposite signs and then with their degree, which is a 2. So therefore, we simply eliminate the variable y. Okay, so therefore, we are going to add them vertically, and the x plus 1 squared added to the x plus 1 squared will answer 2x plus 1 squared. And this is of course eliminated already. And then 5 plus 13 will be 18. Okay, so to get the next step is we're going to isolate the 2 by dividing both sides by 2. Therefore, we have x plus 1 squared is equal to 9. And for that, we are going to extract the square root both sides to get the value of x. So therefore, the result will be, this will be isolated already. So x plus 1 is equal to the square root of 9, which is positive and negative 3. So getting the first root, we have to use the positive 3 first, then transpose the positive 1, that becomes negative 1. So our first root will be 2, or our first value of x is 2. Then the second value will be the negative 3 and then the minus 1. So our second value of x will be negative 4. So to get the value of y, we are going to use the first and the second value. So the x sub 1 is positive 2. So what will be the value of y if this is the case? So we have to use the original equation A, x plus 1 squared minus y minus 2 squared is equal to 5. So the x is 2, so 2 plus 1, and then y minus 2 squared is equal to 5. Then 2 plus 1 is a 3, then that will be 9, minus y minus 2 squared is equal to 5, and that will be negative y minus 2 squared is equal to 5 minus 9. The 9 will be transposed. So negative y minus 2 squared is equal to negative 4. But remember, we cannot extract the square root if the numerical coefficient of this is negative. So we have to divide both by negative 1. So we have y minus 2 squared is equal to negative 4 divided by negative 1 is positive 4. So this time we can now extract the square root both sides. That's it. And then positive, negative. So we have y minus 2 squared is equal to positive negative 2. So to get the first value of y, we have the positive, I'm sorry, this is already isolated. The 2 there is already isolated because we have extracted already the square root, this one. So therefore, we have to transpose the negative 2, that becomes positive 2, and then we will be using the positive 2 first. So 2 plus 2. So the first value is equal to 4. And then the second value is, we have that negative 2 transpose positive 2. Then we'll be using now the negative 2. So 2 minus 2 is 0. So therefore, if we will be using the value of x, which is 2, we have the possible values of y, which is a 4 and a 0. Now let us now solve the value of y if x will be negative 4. So x is equal to negative 4, then what is the value of y? So original equation, x plus 1 squared minus y minus 2 squared is equal to 5. So our x is negative 4 plus 1 squared minus y minus 2 squared is equal to 5. And then negative 4 plus 1 will gives us negative 3, and then squaring negative 3 positive 9 minus y minus 2 squared is equal to 5. So same as we have negative y minus 2 squared is equal to 5. Transpose the 9. So this will become, we have already y minus 2 squared is equal to 5 minus 9 is negative 4, and divided by negative 1 will be positive 4. So still we come up with the same value of our y, which is, this will become y minus 2 is equal to positive negative 2. So the first value of y is uh, 2 plus 2 is equal to 4. And then the second one is y sub 2 is equal to uh, 2 plus, okay, so that will be negative 2 plus 2, then still a 4 and 0 are the values of our uh, y if we will be using the value of x, which is negative 4. Okay, so the solution to the system are, so we have, if x is 2, the value of y will be positive 4 and 0. So we have 2, 4, and then 2, 0. And then when x will be negative 4, there are two possible values of y, which is 4 and still a 0. So these are the four solutions to the system. I will leave you the checking. Okay, so guys, thank you for watching, and I hope you've learned something from my video today. And please do subscribe if you are not yet done subscribing. So this has been Teacher Justina, and thank you for watching. That in all things God may be glorified.